I've been working on this for the last 4 years, and it's finally working the way I had hoped. But there's still significant changes to be made, so let's get into it. The goal with this is daily microgreens. Easy to seed, easy to clean. Otherwise, what's the point? If it's too much work, I'm not gonna do it, let alone you. Let me show you how this gets set up before we get into all the nifty features and tech that it took to actually make this. First step is to drop some water in, slap some seeds in, plug the power in, and then wait. That's it. We're gonna start taking this thing apart and see how it ticks. First piece is the light. This is just a little grow light. You can buy this off of Amazon if you wanted to. It's just got a little timer on it so I can have it at 12 hours on, 12 hours off. Next up we have the 4 pods. These each have seed trays in them. These are 1.4 millimeter holes. I still have some experimentation to do to see if I need different sized ones based on the seeds, but the spicy seed mix that I'm using right now for the microgreens, this is working perfectly. This one is 3D printed and cleaned up a little bit. So this has got a little bit of infill on it and then sanded down and cleaned up. So I took this and made a mold out of it. Using this mold, I was then able to make resin copies of the exact same part. This was using only a single-sided silicone mold, so there is some protrusion on it that I'm unhappy with, so I will probably try to make a 2-part mold with the original to give that a better look. Taking a look, you can see a little bit of water left over from the previous run, along with a few seeds that did end up coming through the holes. The water gets dumped fully into the main base here, which is then sucked up through this custom filter. So this is just a fine steel mesh that is wrapped in a 3D print. That gets sucked up through over to here. The water is getting sucked up through the filter, comes up through and goes through a water diaphragm pump. This pump is controlled by a custom PCB through which a tiny ESP32 is attached to it. And that's just done through just a simple relay to turn it on and off. Once the water gets through the pump, it comes back up through and then hits each of the nozzles. There are 2 nozzles per pod currently. The tray itself has been fully 3D printed. It was too big to print on just my single Prusa Mark IV, obviously. It's 22 inches long. So this ended up being 6 different parts that were then 3D printed and then merged together with super glue. Once it was all done with the super glue, I did some putty fill. That putty fill then got sanded down and then coated in this spray paint fill. Then sanded down, cleaned up some more, and that made it at least watertight. Eventually, it would be nice to make a full mold of this so then I could have one solid container. I've looked into possibly doing ceramics with this. It would be fairly hefty though with the size of this. For the electronics, I ended up making my own PCB. This then has all the components soldered on by hand and then attaching a tiny ESP32 to it. Let's go over some of the changes that I want to make for the next iteration for this, because this is working well, but it's definitely not done. The first thing is I didn't realize how I was going to want to attach the lights. So right now there's these little printed attachments on the back, and so the light just slides in. First off, they need to end up being a little bit higher, sitting roughly about here instead. So it is significantly lower than what I want it to be. Because I didn't know how I was going to attach these at first, they're just super glued on. That's not great. I'd like to actually build this into the base itself. Next up, the way that the water actually flows through here, the pump itself is actually continually pushing the whole thing back and forth, and it eventually just kind of pushes it all the way to the end. So I need to build up this intersection a little bit more sturdy so that then it doesn't move. I'd also like to make some modifications to the filter. So I'd like it to go all the way around for one, and I also want to find a way to fully attach it to the base. That may just be that I end up like attaching it to this piece itself, just as a way to help force it down. The first trial that I did, I ended up getting some roots, some seeds that came in, and the roots ended up getting sucked up because the plastic piece ended up floating up a little bit, and so I was able to get down and in. That ended up clogging a bunch of the nozzles, and I ended up just replacing all of the nozzles, which they are pretty cheap, so it wasn't a big deal, but something I'd like to change in the future. Next, I'd actually like to change the size of the pods. I was originally thinking this would be roughly enough for a single meal, but it's actually quite a bit of microgreens that end up growing on this. So I think I'd actually like to chop this in half, so that then I'll have 8 individual kind of square pods all along this. And that'll help adapt a little bit more to the daily microgreens thing anyway, and make it that much easier to quickly cut, clean, reseed. Now let's look at what an actual harvest looks like. The intention is to use an electric knife, all that power. Now this is the second trial that I did with these. The first trial definitely was not quite as much of a success. I didn't have good lighting on it yet, and I had some early issues with the spray nozzles for the first trial. So trial number 2 went much better and got actually good results. In the end, I ended up with roughly 212 grams of microgreens off of the 4, which is a pretty sizable amount. It's almost half of a pound in microgreens. Now, one thing I'm probably going to get mentioned is that I am using a 3D printed part with plants and so microplastics and such like that. This is printed with PETG, so ideally it doesn't cause too much of that, but there is still a chance of it. But because of that, I want to discuss another option that I've been looking at wanting to do. So this is from a previous prototype. Now this previous one I used an ultrasonic mister, which I really liked the idea of, and I'll show you the footage of that kind of in action. However, as I started looking into it, the way that it's kind of working is atomizing the water, which means it's also atomizing everything else that's in the water. So unless you're using distilled water, who knows exactly what you're atomizing and spilling out into the air and then breathing in. So I ended up going away from this direction, but I did make this, which you can see all the tiny holes. So I made this on my DIY CNC, which you can check that out. That's that 3D printed CNC. And this took a long time. It's 80 holes by 80 holes. It was like 5 to 10 seconds per hole, which you wouldn't think 5 seconds or so is much, but when it's 6,400 holes, that adds up to like 8, 9, 10 hours of CNC time. It took a long time to do this. But this is pure aluminum. This could be anodized and hardened up and made a little bit more long-term durable. So this is something I might like to do. What I ended up doing with this version of it, which let's see if I can get a close-up shot of it, is doing some cups inside of it. So rather than straight through holes like I did in the previous version, these ones kind of cup the seed, but give them a little bit more access to water, and at the same time makes these a lot easier to clean. So I should be able to do the same thing, and ideally do that with aluminum and using a 90-degree bit to just kind of drill down into the aluminum in just one pass rather than trying to do like a boring operation or anything like that. That's still theory though. I don't know how well my CNC 3D printed one is going to hold up with that. So I may look for other options on how to actually make that. So there we go. That's my current microgreens prototype. I'll be moving into a third trial with this system using a different set of microgreens. And then we'll start looking at the next iteration of the prototype. Until next time.